So for this one, it says a particle moves along a line in such a way that its position is given by this function. And it wants to know when the direction changes. So can somebody explain to me, how do we go from position to motion? Yeah, we're going to need to find the change in position, and that means we need to find the derivative of the position. So motion, which is velocity, is going to be the derivative for s. So the velocity is going to be 3t squared minus 12t. Oops, and it looks like I forgot a t here. Plus 9. And it says that's telling us the velocity, but it doesn't tell us when the velocity changes. So how do you know if the velocity changes? Yeah, we only deal with motion along a line, so we only deal with positive and negative for left and left. Well, that'd be right and left if we were to say it in the right order. So that's what we need to figure out here: is when does this thing go from positive to negative? So it's going to be helpful if we factor it first. So this is going to be the positions that I'm working with. So minus, this will be positive, this will be negative, and it'll be positive here. So overall, it's going to be positive there, and positive there. So that means there's a change that happens here because I go from positive to negative. There's another change here because I go from negative to positive. So this might be a good time to remind you that when you're doing, like, this could easily be a question about whether something's a critical point or not. You know, it's tempting sometimes to just look for all the places it equals 0 and throw it out there. But if something's going to be a minimum or a maximum, it actually has to go from a positive to a negative. Or if it's going to be an inflection point, it has to go from negative to positive or positive to negative. You still need to check those number lines I showed you, right? It's not enough to just say, hey, let's look and see if it's 0. If it's a 0, that just tells you this is a possibility that it is a minimum, maximum, or inflection point, that kind of thing. So anyway, maybe not the most applicable to this question, but with those number lines, that's what it should remind you of. So here we have, looks like times 1 and 3, which corresponds to D for our answer.